Hi, I'm Melinda Rose.
And I'm Laura Marshall.
And this is Light Matters for July 20th, 2011.
In this week's show, we learn how UV light affects diamonds and carbon nanotubes, talk with the author of a new report on the fiber optics market, and preview the July-August issue of BioPhotonics magazine.
Diamond may be the hardest naturally occurring material on Earth, but admire a sparkler in sunlight and it will soon start shedding atoms, physicists in Australia discovered. When exposed to intense pulses of UV light, carbon atoms begin to evaporate off the surface of a diamond. The evaporation is so slight that under a typical UV tanning lamp, it would take about 10 billion years to see an observable difference. The discovery shows that diamond can be etched gently instead of through the more damaging process of laser ablation for use in high-performance lasers and more efficient optical devices. The study was published in the journal Optical Materials Express.
Last week, we announced the release of The Market for Fiber Optic Components, a 7-Year Forecast, the new market report from Lauren Publishing. Today, we talk with David Chafee, a 30-year veteran of the optical components industry and the author of the report. The report predicts solid growth between 2011 and 2018, and this growth will be driven by the worldwide race to broadband. Hi, David, and welcome. So tell us, how hot is the fiber optic components market right now?
Laura, the optical components market is very strong right now. In some areas, it is reaching historic levels of production, such as in optical fiber cable and in lasers for fiber optic systems, some of which are being made at the level of more than 1 million per month.
Great. And how will this particular report be useful for the industry in navigating any changes ahead?
It's critical that companies in this field think strategically about how they're placing their resources in the most advantageous manner. This is what we try to help them with in identifying hot optical components areas and geographical areas they need to focus on.
Great. Well, thank you so much for joining us, David, and we look forward to talking to you again in the future.
It's my pleasure, Laura.
The Market for Fiber Optic Components, a 7-Year Forecast, is available in print and digital formats. For more information, visit photonics.com.
To the human eye, carbon nanotubes usually appear as a black powder, but attaching fluorescent chemicals to the tubes and exposing them to UV light causes them to emit in the red wavelength. Carbon nanotubes are excellent electrical conductors. Coupling that trait with high luminescence properties could make these new nanotubes attractive for OLED-based technologies. Another application for the photonic material is molecular detection. Researchers in Warsaw, Poland contributed to the development of the new photonic material as part of the International Fine Lumen Project. The July-August issue of BioPhotonics magazine will appear in mailboxes around the world this week, and Laura has a quick preview of the articles we'll find inside. Laura?
Well, in the cover story, contributing editor Marie Freebody writes about new applications for lasers in ophthalmology, including a less invasive vision correction method and early diagnosis of retinal diseases using OCT. Features editor Lynn Savage writes about the perhaps never-ending search for higher resolution microscopy. Optical microscopy could achieve resolution better than 20 nanometers, further dismantling the Abbe diffraction limit, but achieving this goal would be onerous, his sources say. We also have a contributed feature from Barbara Foster of the Microscopy and Imaging Place. She discusses how the trend toward quantitative fluorescence in live cell imaging requires accurate measurement and calibration of illumination at the sample plane. Another feature by Lynn Savage covers optical spectroscopy and how it gives a sharp gaze into tissues. Optical spectroscopy techniques are becoming increasingly useful in tissue research in both the lab and the clinic.
Well, that's it for this edition of Light Matters. For more on any of these stories, visit photonics.com.
We hope you'll share Light Matters, and you'll find the icons to do so at the bottom of this player.
We'd like to hear from you. Please send your questions or comments to lightmatters@photonics.com. You can also follow Photonics Media on Facebook and Twitter.
Thanks for watching, because if it's light, it matters.